On October 3rd, 3I Atlas will pass within 29 million kilometers from Mars. And we have several orbiters around Mars. One of them is the Mars Reconnaissance Orbiter that NASA launched that can resolve 3I Atlas.
Most space warnings focus on Earth. Not this time. Harvard scientists just raised a red flag over Mars. And now NASA is on alert. The culprit? A comet from outside our solar system that's getting too close for comfort. What's it doing? Where's it headed? And what happens if it hits? Join us as we break down the science, the risk, and the race to figure out 3I Atlas. Harvard's alarming discovery. At first, it was just another day at Harvard's Center for Astrophysics. A new data set came in from a scheduled run on 3I Atlas, an interstellar object that was supposed to pass by Mars at a safe distance. But something had changed. At 2:13 a.m., the orbital models updated. What used to look like a harmless flyby had shifted, now showing a path cutting much closer to Mars. Not just close, but inside the orbit of Phobos, Mars' innermost moon. That's less than 4,000 miles from the surface. The margin of error, which used to span millions of miles, had collapsed to something closer to the distance between New York and Los Angeles. It wasn't a bullseye yet, but it was close enough to make the scientists take notice. Within minutes, the mood shifted. Graduate students reran simulations. Data from powerful telescopes like JWST and the VLT poured in. Each new update slightly changed the comet's path, and each time it moved a little closer to Mars. By noon, the team had started preparing a press release. It wasn't public yet, but the internal message was clear. This might be serious. Emails were flagged, Slack messages were tagged urgent, and cross-campus teams got pulled into the analysis. What triggered this sense of urgency wasn't a confirmed collision, but a drastic change in probability. Risk models showed the odds of an impact were still low, but rising fast. That's what raised the red flag. Even a low chance becomes meaningful when the stakes involve a whole planet. Inside the Harvard labs, high-performance computers ran non-stop. These models, updated hour by hour, kept showing the same troubling pattern. Unless something unpredictable happened, like the comet suddenly changing course due to an outgassing event, it would pass within dangerous range of Mars. This wasn't just a theoretical concern. A comet, moving at nearly 54 miles per second, could cause serious damage even with a glancing blow. And now, for the first time, the path of an interstellar object appeared to thread a needle through Mars's neighborhood, close enough that even a small change in speed or direction could lead to impact. The decision to go public wasn't made lightly, but the shrinking error margin and the growing attention from NASA and other agencies left no choice. Within hours, the alert was out, and the eyes of the space science world turned toward a comet that nobody had worried about until now. JPL's orbital recalculation frenzy. Once Harvard flagged the risk, the next step was clear. Send the data to NASA's Jet Propulsion Laboratory, the world's top team for tracking objects in space. Within hours, JPL's analysts were running fresh simulations, feeding in new data from telescopes around the world and from orbit. What they saw confirmed Harvard's warning, but also raised the stakes. 3I Atlas is now expected to pass about 1.2 million miles from Mars. That may seem like a huge distance, but in space, that's uncomfortably close. Especially considering this object is coming in at a steep angle against the direction most planets orbit, a rare, retrograde path that increases the impact energy dramatically. Even without touching Mars, something that fast passing that close could still create effects, especially if it sheds debris or changes speed at the last minute. And while there's still no confirmation of a direct hit, The updated trajectory now placed 3I Atlas inside NASA's official monitoring zone, a kind of invisible tripwire for high-risk objects. This wasn't just a matter of curiosity anymore. It was now in the category where planetary defense protocols come into play. Inside JPL, orbital engineers ran what's called a Monte Carlo ensemble, a method that simulates thousands of possible paths based on the most recent observations. These simulations help predict how small changes, like a shift in velocity or an unexpected gas release from the comet's surface, might affect its path. Every hour, new numbers were coming in from Hubble, the Deep Space Network, and ground-based observatories. Each one slightly reshaped the comet's possible future. Most of those futures still had it missing Mars, but a few came uncomfortably close. In some extreme scenarios, it skirted closer than Mars' outer moon, Deimos. JPL's analysts flagged the object internally. That means it triggered a set of automated alerts used for high-speed, high-risk flybys, the same ones usually used for objects that could threaten Earth. This was the first time they'd used that system for something heading toward Mars. At this point, the situation had changed from theoretical to operational. NASA's Mars orbiters were now watching the comet's approach. Imaging schedules were rearranged, radar antennas were aimed, and the planetary defense teams, normally focused on Earth, started working late nights for a different reason. Mars was now the center of attention, and 3I Atlas had everyone's full focus. Why 3I Atlas isn't behaving like others? As astronomers tracked 3I Atlas, they noticed something that didn't fit the pattern of a typical comet. Using time-lapse images from observatories around the world, scientists picked up a repeating signal, not in radio waves, but in bursts of gas. Every 17 minutes, almost like a timer, the comet released a jet of gas and dust. This wasn't random. It wasn't caused by sunlight heating one side or cracks forming in its surface. It was too exact. The timing was steady, the force measurable, and the direction seemed to shift slightly as the comet traveled. In short, 3I Atlas wasn't just drifting, it was adjusting. Each one of these gas bursts acts like a tiny engine, giving the comet a gentle nudge, not enough to notice with the naked eye, but enough to change its path, especially over long distances. Scientists describe it like this. If a baseball changed course just an inch every few yards, it could still miss or hit the glove by a mile downfield. Telescopes from Chile to Hawaii confirmed the pattern. Spectral data showed the pulses contained cyanogen and carbon monoxide, common chemicals in comets. But again, the regular timing was unheard of. No known comet behaves this way. Most erupt in uneven, messy patterns as the sun heats their surfaces. But 3I Atlas was releasing its gas like a metronome. Every 17 minutes, give or take a few seconds. This strange, clock-like behavior caused big headaches for the teams calculating its orbit. Orbital models usually assume a comet's path is influenced by gravity and maybe the occasional unpredictable outburst. But here, the outbursts weren't unpredictable. They were constant, and that changes everything. Because of these pulses, every prediction of 3I Atlas's path needs to be adjusted again and again. It's like trying to forecast a flight path while the plane keeps tapping its own controls mid-flight. And here's the concern. If even one of these microbursts happens at just the right angle, it could shift the comet closer to Mars, possibly enough to close the gap between a close flyby and an impact. This is why scientists are paying close attention, not just to the distance, but to the rhythm. A comet that seems to steer itself isn't something we've seen before. Whether it's natural or something else, 3I Atlas has broken the rules. And that adds a new layer of risk to an already tense situation. public opinion meets astrophysical reality. As news of 3I Atlas spread, a big question took over online forums and science shows. If Mars takes the hit, does that protect Earth? It's a comforting idea. Mars is right there in the path, 2 planets closer to the comet than we are. Around 60% of people said they believed Mars would act like a kind of cosmic bodyguard. But that's not exactly how space works. Mars might take the brunt of the impact, but that doesn't mean Earth is completely safe. Scientists ran the numbers. At the comet's current speed and mass, a direct hit would release more energy than any explosion ever seen, enough to blast debris miles into the sky and far beyond Mars's weak gravity. That debris wouldn't just fall back down. Some of it would reach escape velocity, meaning it could fly off into the solar system and, in rare cases, cross paths with Earth. The chances of anything large making it here are low, but not zero. And even tiny fragments, traveling at high speed, could become dangerous. There's also what's known as a halo effect. When a massive impact happens, it doesn't just leave a crater. It kicks up clouds of dust and fine rock that could drift through space for years. These particles might never hit Earth, but they could interfere with satellites, space missions, or even future Mars exploration plans. Still, let's be clear. Mars isn't going to save us. It's not a shield in the superhero sense. If 3I Atlas does hit, Mars won't change course or protect Earth like a wall. It's more accurate to say Mars is simply in the way, and Earth is lucky not to be. Some people have taken the idea further, wondering if the hit could knock Mars off its orbit or cause bigger changes in the solar system. The answer to that is no. Mars is too massive, and space is too stable for an impact, even this large, to shift the balance of the planets. But there's a real psychological shift happening. For once, it's not Earth in the spotlight. We're watching the risk unfold on another world. That raises questions about how we handle threats beyond our own atmosphere and whether we're ready if the next one is aimed at us. Visualizing risk with Monte Carlo models. When tracking an object like 3I Atlas, scientists can't say with 100% certainty where it will go. Not yet. Instead, they use something called a Monte Carlo simulation, which generates thousands of possible future paths based on the most recent data. The result looks like a fan, a spread of curved lines all branching out from the comet's current location. Most of these lines show the comet passing well outside Mars's orbit, far enough to be safe. That's the good news, but not every line stays clear. Along the edges of the fan are what scientists call outliers, rare paths where something shifts just slightly, and the comet gets much closer to Mars. In a few of these paths, 3I Atlas swings in as close as 31,000 miles from the Martian surface. That's closer than Mars' outer moon, Deimos. Now, this doesn't mean a collision is likely. In fact, most models still show a near miss. But orbital dynamics isn't about certainty, it's about probability. And even a very low chance matters when the consequences are this big. Every new piece of data, a sharper telescope image, a radar reading, or a brightness change, helps tighten the fan. As more observations come in, the range of possible paths narrows. The fan gets thinner, and most of the wild trajectories drop away, but not all of them. There's always a tail, a sliver of risk that doesn't fully vanish. It's like predicting a storm. The models might say it will miss your house, but if one variable changes, the temperature, the wind, the humidity, the storm could shift your way. In space, size works differently. What seems like a huge gap on Earth can be dangerously close when you're talking about orbits. That's why NASA, Harvard, and other space agencies keep watching the fan. Not because they expect an impact, but because that thin edge, that low probability tail, is still there, and it only takes one path, one sudden shift, to change the story. For planetary defense teams, the fan isn't just a chart, it's a real-time picture of risk. And as long as that faint edge still brushes against Mars's orbit, the work continues. Every telescope update, every hour of modeling, brings us closer to knowing, will 3I Atlas simply pass by, or will it carve its place into Martian history? Red Alert protocols activated. NASA's Planetary Defense Coordination Office is designed to watch for space threats to Earth, not Mars. But when 3I Atlas started drifting too close to the red planet, that changed fast. New simulations showed the comet's path dipping dangerously near Mars, even closer than its outer moon, Deimos. That put billions of dollars in spacecraft at risk. Mars has a fleet of orbiters and landers from multiple space agencies, and if anything were to hit nearby, those missions could be lost in an instant. Without waiting for public announcements, internal teams at NASA raised the alert level. This wasn't about a likely impact, it was about not getting caught off guard if one occurred. Behind the scenes, things moved quickly. The Mars Reconnaissance Orbiter was told to begin tracking the approach corridor. Imaging schedules were adjusted to capture detailed views of the comet's possible path. NASA's Deep Space Network shifted its antennas to get radar readings. Other countries joined in quietly. The European Space Agency, China's Space Agency, India's ISRO, all began preparing just in case. Mission managers reviewed emergency plans. Some were told to increase data downloads in case communications were disrupted. Others started looking at how fast a spacecraft could be moved or rotated to avoid debris. These were serious steps, the kind normally taken when something threatens Earth's orbit, not Mars. There were no public press conferences, no headlines, just a chain of encrypted messages, technical bulletins, and silent coordination. The mood inside those control rooms was focused. Engineers and analysts knew this wasn't a practice run. For the first time, Earth's planetary defense system was being redirected, not to protect Earth, but to defend machines on another planet. The urgency wasn't just about impact probability, it was about the cost of doing nothing. Mars holds decades of science, hardware, and investment. If something were to go wrong, we'd lose more than metal and sensors. We'd lose years of progress, and possibly the ability to send new missions anytime soon. This situation pushed planetary defense into new territory. It forced a question no one had to ask before. What happens when the threat isn't to us, but to something we've built far away? They didn't need to be sure. The margin was shrinking fast, and with something this massive, even a slim chance was reason enough to respond. What happens if it hits? If 3I Atlas were to strike Mars head-on, the result would be unlike anything we've ever witnessed on the Red Planet, or anywhere in our solar system in modern times. If it hits, the energy released would be equal to about 2 million megatons of TNT, far beyond the largest nuclear blast ever recorded on Earth. That kind of force would carve out a crater roughly 37 miles wide and over 3 miles deep. To put that in perspective, that's more than 30 times the size of Arizona's Meteor Crater, and deeper than the Grand Canyon in some spots. It wouldn't just be a dent in the ground, it would be a hole punched deep into Martian bedrock. The shockwave from the impact would travel across the planet's surface, likely knocking out orbiters and damaging equipment on the ground. Spacecraft circling Mars, like NASA's MAVEN and ESA's Trace Gas Orbiter, could be hit by debris or damaged by the intense radiation and dust kicked up into space. On the ground, the Perseverance rover, located over 1,800 miles away from the likely impact zone, might survive. but survival wouldn't be guaranteed. Ejecta from the blast could circle the planet, hitting equipment thousands of miles away. Thin as it is, the Martian atmosphere wouldn't be enough to slow the incoming debris. Solar panels on landers and rovers could be buried in dust. Communication systems might go offline. Years of carefully gathered climate data, geology records, and signs of ancient water could be lost. Even backup systems on Mars rely on steady orbiters to transmit their signals. If those orbiters are taken out, the entire Mars network could go dark. Engineers on Earth have already started running impact simulations to understand what could survive and what wouldn't. Most of the conclusions point to the same thing. If 3I Atlas hits directly, almost nothing nearby makes it through intact. And while the impact would be local in terms of damage, the effects wouldn't stop at the crater's edge. Dust clouds would rise high into the atmosphere and could be seen from Earth with large telescopes. It would be the first time humans watched a deep space impact this closely. But it might also be the moment we realize just how fragile our foothold on another planet really is. Climate catastrophe on Mars. If 3I Atlas hits Mars, the damage wouldn't end with the crater. The real story might begin after the impact, in the form of a planet-wide climate shift that could last for years. The blast would throw huge amounts of dust and debris into the Martian sky. Unlike Earth, Mars doesn't have strong weather systems or a thick atmosphere to clean that up. Instead, fine dust could linger in the air, blocking sunlight from reaching the surface. Temperatures would drop sharply, and what scientists call a Martian winter could settle in. Now, Mars is already a cold planet, but this would push it even further. Some areas could freeze solid, and surface operations would become extremely difficult. Solar-powered rovers and instruments would struggle to function with less light and colder conditions. Then there's the issue of the atmosphere. Mars's air is thin to begin with, and impacts this powerful can cause shock waves that push gases into space. That means what little air Mars has could slowly bleed away faster than normal. At the same time, underground ice layers exposed by the blast would turn to vapor. But instead of forming clouds or snow, much of that vapor would be lost into space as well. In the sky above, broken pieces of rock and dust would likely form a temporary debris ring around the planet. This ring wouldn't be pretty. It would be dangerous. Orbiters could be damaged or destroyed by high-speed impacts. Planning future missions would become much harder, with flight paths restricted and landing zones more risky. It's not just the robots that would be affected. Scientists and engineers looking toward human missions to Mars would have to rethink everything. From power systems to life support, all plans rely on predictable weather, available sunlight, and clear communication with Earth. A single impact could throw all of that into uncertainty. Even the search for signs of past life on Mars could be disrupted. Instruments meant to study ancient rocks or ice might be buried, broken, or rendered useless by the chaos following the collision. In short, a direct hit by 3I Atlas wouldn't just make a mark on the planet. It could rewrite Mars's environment. It would likely delay future missions by years. And for those hoping to one day walk on the red planet, this event would be a harsh reminder. Space isn't just distant, it's dangerous. The Shoemaker-Levy wake-up call. Back in 1994, a broken-up comet called Shoemaker-Levy 9 slammed into Jupiter. It didn't hit the surface. Jupiter doesn't really have one. But the explosions in its thick atmosphere were so massive, they left scars bigger than Earth. Telescopes around the world watched the impacts in real time. It was a wake-up call. That event showed the world just how real and how powerful space collisions can be. It changed the way scientists and space agencies thought about risk. And in the years that followed, Earth got serious. We built survey telescopes to find asteroids. We built computer systems to model orbits. We created emergency protocols for what to do if something came too close. And just recently, NASA even tested a way to nudge an asteroid off course. The DART mission. But here's the problem. That entire system is focused on Earth. There are no warning networks for Mars, no international agreements on how to respond if a comet threatens another planet, no coordinated plan to protect the robotic missions we've spent decades building and billions of dollars launching. And that's what 3I Atlas has revealed. A blind spot in our thinking. We assumed the next danger would come toward us, but what happens when the threat is aimed somewhere else? Right now, space agencies are scrambling to catch up. NASA, the European Space Agency, and others are quietly talking about what shared protocols might look like, how to coordinate data, how to respond faster, and how to protect high-value assets on distant worlds. Private companies are also stepping in. Groups like SpaceX and Lockheed Martin, which plan to send people and equipment to Mars in the future, are pushing for clearer rules and faster warnings. But all of this is happening under pressure. There's no system in place yet. And if 3I Atlas does something unexpected, if it suddenly shifts and heads toward Mars, we may not have time to respond. The lesson from Shoemaker Levy 9 was that giant impacts do happen, and they can happen in our solar system, right before our eyes. The lesson from 3I Atlas may be different, that watching isn't the same as being ready. So now, as the comet continues on its path, the space community faces a choice. Treat this as a one-time scare, or take it seriously as a warning shot, not just for Earth, but for every world we've touched. The countdown continues. As of right now, we don't know how this ends. The comet 3I Atlas is still on track to pass close to Mars, but how close is still up for debate. The numbers are constantly changing. Every time new data comes in, whether it's from a telescope on Earth or a space observatory, the models get updated. And while most of those models show a safe pass, not all of them do. A few still point to a dangerously close encounter, even a possible impact. Part of the challenge is how unpredictable this object is. It's moving incredibly fast, around 54 miles per second, and every 17 minutes, it releases a burst of gas. These small jets act like mini thrusters, slightly changing the comet's path. That makes it harder to predict where it will be, even a few days from now. The mass of the comet is also uncertain. Some readings suggest it's heavier than expected, with a possible metallic core. That would make any collision far more powerful. And because of its speed and steep path through the solar system, there's very little time to react if it suddenly changes course. Right now, NASA, Harvard, and observatories around the world are watching closely. Teams are comparing models, recalculating the orbit, and preparing for any scenario, whether it's a near miss, a flyby, or something worse. The latest projections still show a wide range of possible outcomes. Scientists call this spread a fan diagram, a shape that shows all the paths 3I Atlas might take based on current information. Most of those paths avoid Mars, but a few don't. And until those narrow edge cases disappear completely, the concern stays. What's unusual about this moment is that the whole world is watching, not just the science community. For once, the target isn't Earth, it's another planet. But the impact, if it happens, would still matter to us. Mars is home to some of our best work in space exploration, and possibly our future as a species. The countdown continues. Every new observation helps close the gap between probably safe and definitely safe. But we're not there yet. The story of 3I Atlas isn't over. It's still unfolding. and the final chapter will be written by the next data point. Thanks for watching. What part surprised you the most? Let us know in the comments. We'd love to hear your take. If this caught your interest, hit like and subscribe so you don't miss what's next. We've got more space stories coming your way. See you in the next one.